Discussion of statistical mechanics that we used in physics, especially used in fundamental particle physics and other branches. Now, basically two types of statistics we used in statistical mechanics, or especially in statistical physics. One is classical statistics and another is quantum statistics. The particle, those follow the classical mechanics, classical statistics or classical mechanics. For that case, we used the classical statistics. This classical statistics is usually called as Maxwell statistics, and the particle, those follow the Maxwell-Boltzmann statistics. We called it as a Boltzmann particle. And another one is quantum statistics. For quantum statistics, basically two types of statistics we discussed in the statistical mechanics. One is Bose-Einstein statistics and Fermi-Dirac statistics. The particle, those follow the quantum mechanical rule. For this particle, for this kind of particle, we apply the quantum statistics. Here we also see that two types of statistics are there. One is Bose-Einstein statistics and Fermi-Dirac statistics. Those particles follows the Bose-Einstein statistics. These particles are called as bosons, and the particle those followed by Fermi-Dirac statistics, this kind of particles are called as Fermi particle or fermions. These are bosons, these are fermions, and generally we can talk like that. These are Boltzmann particle, these are bosons particle, these are fermions particle. Now, what is the difference between classical statistics and quantum statistics? First, we will discuss this one. So, for classical statistics, first condition should be the particles should be distinguishable. That means, if we consider a particle A like that and another particle B like that, these are identical. Sorry, these are not identical. These are distinguishable, and we can easily identify them properly. We can identify them properly because it has some color, it has different types of color. Using this thing, we can distinguish it properly. So, for classical statistics or Maxwell-Boltzmann statistics, we can distinguish the particle, or the particle should be distinguishable for the Boltzmann particle or the classical statistics. And for quantum statistics, there is no existence of distinguishability. Means these are indistinguishable particles. Means if two particles are there, we know that in the quantum nature of the particle, we can't imagine like that. We have to imagine the concept of wave function. So if we imagine this particle wave function is like that and this particle wave function is like that, so both wave function will be superimposed. So we cannot identify each of the particle. So there is no any concept of distinguishability. Means they are indistinguishable. This is the basic difference between the classical statistics and the quantum statistics. And now, what is the counting? Now, if we discuss about the Boltzmann particle, the counting process or counting probability or the distribution probability should be this one, and the distribution function will be this one. And generally, the real gaseous system, any classical particle system follows these statistics, and there is no any spin concept. There is no any spin concept that we used in quantum mechanics. And as they are indistinguishable, or as they are distinguishable particle, so if two accessible states are there, if one particle A is here and another particle B is here, we can easily identify this particle. This is the classical statistics. And if we talk about the quantum statistics, one statistics is Bose-Einstein statistics, named from two renowned scientists, one Einstein and Indian scientist, S.N. Bose. They gave these statistics, and the counting process and the counting probability is like that, and the distribution function is like that. And here, main difference between the Bose-Einstein statistics and Fermi-Dirac statistics is the spin of the particle that follows Bose-Einstein statistics. It should be even integer of h cut, or we can not even integer, it should be the any kind of integer number into h cut. And for the spin that followed by the Fermi-Dirac statistics should be equal to the fraction, that means 2n plus 1 by 2, that kind of spin angular momentum follows by this statistics. And another important things is, for Bose-Einstein statistics, in one accessible state, bosons can access any number of particles can access one single state. Here, only one particle can access only one single state. Means one single state can be occupied by one single particle only for the Fermi-Dirac statistics, like electron. That's why we know that electron and the Fermi particles that follows the Pauli's exclusion principle. That means they, for each state, only single particle can occupy a single state. I mean, each state can be occupied by the single particle. But for bosonic particle or for bosons, any number of particle can access one single state. And another thing, here the total number of particle of any system, of any quantum system, is not a constant. May be constant or cannot be a constant. For some cases, we can see that the particle number may be constant or may not be constant. This is the basic difference between the Bose-Einstein statistics and Fermi-Dirac statistics. The main difference, and another is their distribution, different types of distribution we can see here. And for symmetric, the boson particle maintain the symmetric rule. That means if the wave function of first particle or A particle is psi 1 and B particle is psi 2, then we can arrange the total wave function should be this one. For the fermion, we can it cannot maintain the symmetry, so we can write this equation like this. This is the basic discussion about the statistical mechanics that used in physics. And if the person, those are far beyond this physics, how can they realize this kind of phenomena or this kind of statistics? Because as we are Indians, we feel proud, we are feeling proud because of the bosons. Because bosons comes from the name Bose, who is the renowned scientist of India, especially from Bengal. And so everybody knows the name Bose-Einstein stat, every Indian people. But how can they realize in this perspective of the quantum mechanics? It is very difficult to analyze or realize this thing. But if we discuss easily, then you can understand it little bit. It helps to realize this thing. We can make some analogy, physical analogy. Using this, you can realize this thing very easy. We can make a story like that. Let us make a building. Let us make a building. Let us take a multi-storied building which has lot of rooms. This one, lot of rooms. And consider that only Indian people and the Chinese people can access this building. So if we make the story like that, at first this is the IPL season, a lot of people are interested about to see the IPL match. But in some cabin of this building have some Super AMOLED display TV. There are some Super AMOLED display TV. In this TV, you can watch this match. You can watch this IPL or any international match that is happening now. So, if we allow some Indian men, if we allow this Indian men to access this building, so what will be the process of distribution? So maximum number of men, Indian men, they occupy this type of room where the television is there. So maximum number of men, they access this kind of room. Maybe let us consider 100 men can access this building. So among them, 30 men are there. There are 20. Then again 35. Then again 10, and another 5 peoples are here one, here two, because they want to use washroom or any kind of they want food or washroom, so they access this compartment, and rest of the people, they access the TV room where they can see the matches. So this will be the distribution of the people, of the Indian men, if they access this building. So this is like the Maxwell-Boltzmann distribution, because we know that every Indian people is distinguishable. Means we can easily identify we can identify man to man in this compartment using seeing their face and their characteristics. We can easily identify seeing their faces. And another thing means they are distinguishable. And another thing, they can access, means any single compartment can be accessed by a lot of men. So we can compare it as a Boltzmann particle. And now the second case, if we allow the Chinese men to access this building, then what will be the distribution? Distribution will be same because men are they are very enthusiastic, and they are very engaged in the playing and entertainment like things. So they will behave similar kind of thing like that. But main thing, we cannot identify these Chinese men because they look like similar. They have blunt nose, and the face is they're short, kind of. Their height is short, and the color is, all the peoples are white in color. So they are not distinguishable. They are one kind of they are similar thing. They are similar nature. To see them, we cannot identify them properly. So we can tell that they are one kind of Boson's particle. And same thing it will have if we allow the Chinese woman to access this building. Then what will be the distribution? If 100 women Chinese women are access in the building, let us consider here 90 compartments are there. So what is as a human being, what is the nature of the woman? Basic nature of the women is they can tolerate any other in their private area or private place, and they want some private space, so they can't allow their bedroom or in kind of private area to another. So they behave, they must occupy a single room individually they can occupy a single room. So only 90 women can fill this apartment or this building, and rest of 10 they will left the places. Why I tell the Chinese women? Because Chinese are looking like similar, so we cannot identify them using their faces. Like, we cannot identify like that because they have blunt faces and blunt nose, and height is short, and they're looking their face is white kind of, so we cannot identify them properly using by seeing their faces. So they are indistinguishable, and they can access one single state in a particular time. So we can consider that they can follow the thermodynamic statistics, or we can tell that the people are Fermions. This is the basic difference between them. We can understand it using the analogy